So this is my next session on quadratic inequalities. It is the last lesson on quadratic equations. And I have been teaching math at the high school level for close to 2 decades, and I have made these videos to help simplify mathematics to you. In this lesson, you will learn about quadratic inequalities and how to solve them using the method of intervals. And this is useful in applications of derivatives where you need to find out the interval in which a function is increasing or decreasing. It is actually decreasing. So what do you mean by a quadratic inequality? Any equation of the form ax squared plus bx plus c greater than 0 or greater than or equal to 0 or ax squared plus bx plus c less than 0 or less than or equal to 0 is called a quadratic inequality. For example, if I have this is the open interval 2, 3. So it has all the elements x lying between 2 and 3 but not including 2 and 3. The closed interval 2, 3 is denoted by all the set of elements x where 2 less than or equal to x less than or equal to 3. So what is the difference between the open interval and the closed interval? Open interval you include the endpoints, closed interval you do not open interval you do not include the endpoints, closed interval you include the endpoints. For example, if I say 2 to infinity, it will be the set of all elements x greater than 2. And it is this set here. Minus infinity to 2 will be the set of all elements x less than 2. It's the set of all elements to the left of 2. And do we include 2? No. If I say the closed interval 2 to infinity, it is the set of all elements x greater than or equal to 2. This part here, including 2. And closed interval minus infinity to 2 will be the set of all elements x less than or equal to 2 and including 2 as well. Now ax squared plus bx plus c greater than 0, if the roots are alpha and beta, where alpha is less than beta, we will divide the interval into, we'll plot alpha and beta on the number line and then divide it into two intervals. And we start with plus starting on the rightmost interval and do alternate plus and minus. So you can say that it is greater than 0 when x greater than beta or x less than alpha, or you can write it as beta to infinity union minus infinity to alpha. So this convention is very important. We divide it into intervals depending on how you position it on the number line, and then you put alternate plus and minus starting from the rightmost interval. What about ax squared plus bx plus c greater than or equal to 0? Again, if the roots are alpha and beta where alpha less than beta, we position it into intervals and we say that we divide it into plus and into intervals and write plus or minus starting from the rightmost interval. So greater than or equal to 0 means you look at plus. So it will be x greater than or equal to beta or x less than or equal to alpha. That is the solution set. Or you can write it as minus infinity alpha including alpha union beta infinity including beta. And ax squared plus bx plus c less than 0. The roots are again alpha beta where alpha less than beta. Less than 0 means negative. So you can say that the solution set is alpha less than x less than beta or the open interval alpha to beta. And ax squared plus bx plus c less than or equal to 0 if the roots are alpha beta where alpha less than beta. So where will be the solution set? Where is it negative? Alpha to beta. Only thing is because we have less than or equal to 0, we will write alpha less than or equal to x less than or equal to beta, or the closed interval alpha to beta. So when it is less than 0, we write open interval. When it is less than or equal to 0, we write the closed interval. Coming to questions, solve 4x squared minus 9 greater than 0. So first step, what do? We factorize. So the roots are, we factorize into 2x plus 3 into 2x minus 3 greater than 0, and we need to check if the coefficient of x squared is positive. It's positive here. So we divide it into intervals. The roots are 3 by 2 and minus 3 by 2, and we plot it on the number line and write plus or minus starting from the rightmost interval. Now when is it greater than 0? Here and here. So the solution set is minus infinity to the open interval minus 3 by 2 union the open interval 3 by 2 to infinity. Next question. Solve 2x squared plus x minus 15 greater than or equal to 0. So here again the coefficient of x squared is positive. So if we factorize, you get x plus 3 into 2x minus 5 greater than or equal to 0. So what are your roots? Minus 3 and 5 by 2. So if you plot it on the number line, again you write alternate plus and minus, and what is the question? It is greater than or equal to 0. So what is the solution set? Minus infinity to the closed interval minus 3 union the closed interval 5 by 2 to infinity. Why is there a closed interval here? Because you have the greater than or equal to sign. Next question. Solve 2x squared plus 9x plus 4 greater than 0. Again, briefly check if the coefficient of x squared is positive. It is. So when you factorize, you get x plus 4 into 2x plus 1 greater than 0. So what are your roots? Minus 4 and minus half. And what the question is, it is greater than 0. When is it greater than 0? Minus infinity to minus 4 not including minus 4 union minus half to infinity not including minus half, because we have strictly greater than 0. Next question. Solve for x into x minus 2 into x minus 5 into x plus 3 greater than 0. Again the coefficient of x squared is positive. Here they have already factorized it for you. So the roots are minus 3, 0, 2 and 5. We plot it on the number line and write alternate plus or minus starting from the rightmost interval. So where is it positive? Minus infinity to minus 3 union 0 to 2 union 5 to infinity. And we write open interval because we have strictly greater than 0. Next question. Solve x cubed into x minus 1 into x minus 2 greater than 0. Again the coefficient of x squared, is it positive or negative? It's positive. So the roots are 0, 1 and 2. So we plot it on the number line and write alternate plus and minus starting from the rightmost interval. And when is it plus? When it is open interval 0 to 1 union open interval 2 to infinity. Again I am writing an open interval because we have strictly greater than 0. Question 8. Solve x plus 1 into x minus 3 by x plus 2 greater than or equal to 0. Now here we are not going to, we have a denominator here. We cannot cross multiply, and why is that? Because we don't know if x plus 2 is positive or negative. If x plus 2 is negative, greater than or equal to becomes less than or equal to. So the technique which we are going to use is we are going to multiply both sides by x plus 2 the whole square. The right hand side anyway becomes 0. So this becomes x plus 1 into x minus 3 into x plus 2. So we have removed from the denominator, we have removed x plus 2 and brought it to the numerator. And the roots are minus 1, minus 2 and 3. We plot it on the number line and write alternate plus and minus starting from the rightmost interval. And we have to look at the positive sign. So the solution set is minus 2 to minus 1. The semi-closed at minus 2 union 3 to infinity. Why do we put open at minus 2? Because your denominator is x plus 2 and you cannot have x as minus 2. So you have to remember this step, why it is open at minus 2. Next question. Find the values of x for which 3x squared minus 2x minus 5 by x squared minus 2x plus 5 less than 2. Again we have a denominator here. So first we shift minus 2 to the left. So I get 3x squared minus 2x minus 5 by x squared minus 2x plus 5 minus 2 less than 0. Take the LCM. So I get 3x squared minus 2x minus 5 minus 2 into x squared minus 2x plus 5 less than 0. So when you simplify, you get x squared plus 2x minus 15. And how do I get rid of the x squared minus 2x plus 5? Same procedure what we applied in the last problem. We multiply both sides by x squared minus 2x plus 5 the whole squared. So the right hand side anyway becomes 0 since it is a 0. And here we are only going to look at this part. The other part is complex root, x squared minus 2x plus 5. We are dealing with the real line only. When you factorize x squared plus 2x minus 15, what do you get? X plus 5 into x minus 3. So the roots are minus 5 and 3. Draw it on the number line and put alternate plus and minus. And when is it less than 0? In the open interval minus 5 to 3. We have the open interval because it is strictly less than 0. Next question. Find the value of x for which x squared plus x plus 1 by x squared plus 2 less than 1 by 3. So we take x squared plus x plus 1 by x squared plus 2 minus 1 by 3 less than 0. Take the LCM, that is 3 into x squared plus 2. So I get 3 into x squared plus x plus 1 minus of x squared plus 2 less than 0. Simplifying, you get 2x squared plus 3x plus 1. And again I am multiplying numerator both sides by x squared plus 2 the whole squared, as we did in the last problem. So again x squared plus 2 gives you complex roots. And when you factorize 2x squared plus 3x plus 1, what do you get? X plus 1 into 2x plus 1 by 3 less than 0. So your roots are minus 1 and minus half. Plot it on the number line and write alternate plus or minus. Again notice that the coefficient of x squared is positive. And when is it less than 0? In the open interval minus 1 to minus half. We are putting open interval because we have strictly less than 0. Next question. If x is real, show that x squared minus x plus 1 by x squared plus x plus 1 takes values between 1 by 3 to 3. So we call let y equal to x squared minus x plus 1 by x squared plus x plus 1. So I have x squared minus x plus 1 by x squared plus x plus 1 minus y equal to 0. Take the LCM. So I get x squared minus x plus 1 minus y into x squared plus x plus 1 equal to 0. So factorizing, you get, open the bracket, you get x squared minus x plus 1 minus yx squared minus yx minus y by x squared plus x plus 1 equal to 0. Can you cross multiply here? Yes, because you have an equal to sign. So when you simplify the left hand side, you get 1 minus y bracket x squared plus minus 1 minus y into x plus 1 minus y equal to 0. So we have got a quadratic in x and x is real. So what can you say about the discriminant? It is greater than or equal to 0. So b squared, that is minus 1 minus y the whole squared minus 4ac, that is 4 into 1 minus y the whole squared is greater than or equal to 0. Open the bracket and simplify. What do you get? You get minus 3y squared plus 10y minus 3 greater than or equal to 0. Now a word of caution here, whenever this method will work only if the coefficient of x squared is positive. Here the coefficient of x squared, y squared is negative. How do I make it positive? Multiply by minus sign, and when you multiply by minus sign, the greater than or equal to becomes less than or equal to 0. So I have 3y squared minus 10y minus 3 less than or equal to 0. So factorizing, I get y minus 3 into 3y minus 1 less than or equal to 0. So again, your roots are 1 by 3 and 3. Divide it into intervals and write alternate plus or minus starting from the rightmost interval. And when is it greater than or equal to 0? Minus infinity to 1 by 3, 3 by 3 to infinity. So y takes values, when is it less than or equal to 0? Between 1 by 3 and 3. So you say that y takes values between 1 by 3 and 3. This is an important question asked a couple of times in the sample paper and the ISC exam. Next question. If y is real, show that x minus 1 into x plus 3 by x minus 2 into x plus 4 cannot lie between 4 by 9 and 1. So if I call y as x minus 1 into x plus 3 by x minus 2 into x plus 4, what do you get when you open the bracket? Y equal to x squared plus 2x minus 3 by x squared plus 2x minus 8. Cross multiply, so you get yx squared plus 2xy minus 8y equal to x squared plus 2x minus 3. So you get a quadratic in y, that is x squared into y minus 1 plus x into 2y, quadratic in x squared into y minus 1 plus x into 2y minus 2 plus 3 minus 8y equal to 0. Now y is real, so what can I say about the discriminant? It is greater than or equal to 0. So I have 2y minus 2 the whole squared minus 4 into y minus 1 into 3 minus 8y greater than or equal to 0. So when you factorize, what do you get? You get 9y squared minus 13y plus 4 greater than or equal to 0. When you factorize this, what do you get? You get y minus 1 into 9y minus 4 greater than or equal to 0. So what are the roots? 4 by 9 and 1. Again we plot it on the number line and divide it into intervals starting with the plus sign and alternate plus and minus. So y is positive. So y cannot lie between 4 by 9 and 1. Next question, solve minus x squared plus 3x minus 2 greater than or equal to 0. Again here, the coefficient of x squared is negative. So what do? We have to make it positive. How do we make it positive? We multiply by minus 1. So I get x squared minus 3x plus 2 less than or equal to 0. Factorizing, you get x minus 2 into x minus 1 less than or equal to 0. So these are your divide it into intervals, roots are 1 and 2, and write plus or minus starting from the rightmost interval. So when is it less than or equal to 0? In the closed interval 1 to 2. We are including 1 and 2 because we have less than or equal to 0. Solve minus 2x squared plus x less than 0. Again, what is the coefficient of x here? It is negative. So we multiply by minus 1 to make it positive. So less than becomes greater than. So I have 2x squared minus x greater than 0, or x into 2x minus 1 greater than 0. What are your roots? 0 and half. So again we divide it into intervals. Starting with the rightmost interval we put plus. So when will it be positive? Minus infinity to 0, union half to infinity. Do we include 0 and half? No, because we have strictly greater than 0. So you have learned how to solve quadratic inequalities. I hope this will help you in your further study in calculus. And practice each slide, each line along with me. That is the only way you can learn mathematics. Thank you.